So with this learning objective, we're going to start our big, long process of learning about trigonometry for the rest of the semester. All right, so trigonometry has to do with this thing that we're going to call Soh-Cah-Toa. And we're just going to keep building on that throughout the rest of our units. All right, so the first thing, all right, similar triangles are triangles whose angles are the same. So the easiest way to draw similar triangles is kind of put one inside the other. We have this smaller triangle, which I'm going to outline in red. All right, that's inside of this bigger triangle in blue. Right. And these are similar triangles because these angles are going to be the same. These bottom angles are also going to be the same. And of course, they share that top angle A, so those are the same. All right, so these similar triangles are an important kind of just thing in geometry. We're not going to talk about them a bunch, but the interesting thing with similar triangles is the ratio of their sides are the same. So if for the little triangle, we call this like side A and the side B. That same side, let's call it, I don't know, Z and Y. If I take the ratio of the smaller triangle, A over B, that's equal to the same ratio of the bigger triangle, Z over Y. All right, so the ratio of the sides of similar triangles is constant. They're the same number. All right, since the ratios of the sides of these are constant, if I don't change the angles, it's helpful to give them a name. So a lot of times in math, if something keeps coming up and it's the same value over and over again, just like we've seen with kind of pi, we talked about with e before, something comes up a lot, we're going to give it a name. And we're going to call these ratios, we'll call them sine, cosine, and tangent. All right, so these are our, what we'll call our trigonometric functions. For most of it, we'll just simplify and call them trig functions because it's shorter than saying trigonometric functions. All right, but these are our new types of functions which just represent the ratios of the sides of a right triangle. All right, so here's the definition. All right, I'm actually going to give a simpler definition in a second, but this is kind of the initial definition. All right, we're given some angle A. So these trig functions all depend on the angle. So our angle A is here. So this is the angle I'm focused on. So the sine of this angle, so sine is abbreviated sin. So just like log, you have to write out what function you're doing. So actually write out the letters sin to say I'm doing the sine function. The sine function is the ratio of this a value divided by that c value. The cosine, so I write out cos as cosine. The cosine of the angle A is this b value, or this side, divided by the hypotenuse c. And the tangent of this angle A is the a value, this a side, divided by this b side. So these are just kind of the basic definitions. It's all dependent on what the angle is. So if I were to change and try to figure out for b, all these letters that I use for the definitions would change. So we don't really like these definitions. So the way that we remember kind of the ratios that corresponds to each trig function is like this. So again, it all depends on A, or what angle you talk about. So we're talking about this angle A. All right, we're going to label the three sides of our right triangle depending on that angle. So the easiest one is the hypotenuse, because the hypotenuse never changes. It's always across from the right angle. That's my hypotenuse. And then there's two other sides, and you can see kind of from the bottom, it's adjacent and hypotenuse. So, or sorry, opposite. So opposite is across from my angle. That's my opposite side. And adjacent is the one that's touching my angle. Adjacent means next to. So it's touching my angle, but it's not the hypotenuse. So I always start off with labeling the hypotenuse, and then probably the adjacent because the other one that's touching my angle, and then the opposite, of course, is across the triangle. All right, so these are going to be convenient ways to label our triangle. And again, it's always dependent on what angle I'm talking about. So if I was talking about B, these things would change. But with the angle A, I have opposite, adjacent, and hypotenuse. Sine is going to be the opposite side divided by the hypotenuse, so A over C, which is the same thing it said on the last slide. Cosine is the adjacent side over the hypotenuse, which is B over C, same thing it said on the last slide. And tangent is opposite A over adjacent B. All right, so these are just the ratios of the sides represented by each trig function. And then how do we remember this? This doesn't, in terms of memorizing, this doesn't help any more than just remembering a bunch of letters. But this is where the acronym that the title of this video is Soh-Cah-Toa. All right, so it's a kind of phrase that's kind of easy to say, Soh-Cah-Toa. And the way it's spelt tells you what the ratio is. So the first letter represents that S is sine. Then the ratio of the sides tells us it's O, opposite, over H, hypotenuse. So tells me that sine is the opposite side divided by hypotenuse. C represents cosine, and cosine is the adjacent side divided by the hypotenuse. All right, and the last one, tangent for T is the opposite side divided by the adjacent side. So just saying Soh-Cah-Toa or being able to write Soh-Cah-Toa down is the simplest way to remember all three of these ratios. All right, so now what we're going to do, we're going to be given an angle we care about, in this case K. We're going to find the trig ratios based on that angle. So the first one we want to do is sine of K. All right, sine of K is the opposite side divided by the hypotenuse, right? Because Soh-Cah-Toa, let me write it up here so it's helpful. Right. So first, let's identify our sides. So I always start with the hypotenuse. So this is my hypotenuse. The adjacent side is the other one that's touching my angle, so this is adjacent. And then that leaves opposite to be across from my angle. All right, so those are my sides. The only problem right now is I don't know the hypotenuse. Or sorry, the opposite side. I know the hypotenuse is 35. I don't know the opposite side. But this is why we know the Pythagorean theorem. If you ever have two sides of your right triangle, you can always find the third one using the Pythagorean theorem. So remember, with the Pythagorean theorem, the hypotenuse goes by itself, and the other two go on the other side. That should be a plus sign. All right, so again, I'm going to have to use a calculator. 35 squared is 1225. 21 squared is 441. Or plus x squared. All right, so I'm going to subtract 441 from both sides. That gives me 784 equals x squared. I take the square root of both sides to get x equals the square root of 784. All right, now let's see if we can simplify that at all. Square root of 784 is 28. So it actually comes out nicely to just be 28. All right, so now I want to do sine is the opposite side. We just figured out that's 28 over the hypotenuse, and that's 35. And both those numbers are divisible by 7, so if I divide everything by 7, I get 4 over 5. So my final answer for sine is 4 over 5. All right, cosine is adjacent over hypotenuse, because it's Ca, C-A-H, adjacent over hypotenuse. Adjacent side is 21. Hypotenuse is 35. Again, they're both divisible by 7, so I'll write this as 3 over 5 as my final answer. And lastly, tangent is opposite over adjacent, because it's Toa, T-O-A. Opposite was 28. Adjacent is 21. Again, all divisible by 7. I get 4 over 3. All right, so this is how you figure out sine, cosine, and tangent. Almost all these problems, you're going to do the Pythagorean theorem first to figure out that missing side you don't know. Then you just do the appropriate ratio for each individual trig functions, making sure you just have Soh-Cah-Toa memorized. All right, so for this one, I'm going to find tangent of A. So again, I'm always going to start off with identifying the angle I care about, because that changes stuff. So then I have my hypotenuse, my adjacent side, and my opposite side. All right, if I want to find tangent, Soh-Cah-Toa tells me Toa is opposite over adjacent, but I don't have the adjacent side. So again, I'm going to call that x for now and figure out what this adjacent side is going to be. All right, 26 squared is 676. I can actually do 100 squared in my head. That's 100. And 576 equals x squared. Again, take the square root of both sides. So x is going to be the square root of 576, which comes out to be 24. So again, this one's pretty nice. We get an exact answer of 24. And now our final answer, the opposite side was 10. The adjacent side is 24. Both those numbers are even, so I can simplify to 5 over 12. All right, so 5/12 is the tangent of this angle A. On this one, we want to find sine of z. All right, so again, z is the angle I care about. I have hypotenuse, adjacent, and opposite. And if I want to find sine of z, so tells me sine is the opposite over the hypotenuse. And I get lucky in this one. I don't actually have to do the Pythagorean theorem because I already know the opposite side's 12, and the hypotenuse is 13. So that one I'm just done, because I already had the sides that I needed. All right, so here you have to find cosine of c. So go ahead and try this one on your own. And the final answer you get is 5 over 13. Again, this one we're lucky because the sides we were given are actually the two we need for our trig function. They give us the adjacent side's 10. The hypotenuse is 26. All right, they're both even. Our final answer is 5 over 13. All right, so for this learning objective, you're going to have to do problems on delta math. I used to do 4 problems at 2 different difficulty levels.